All right, guys, we're going to analyze graphs of polynomial functions. Quite a bit of stuff here. Hang on there, and we'll get it. Three huge words, or four huge words. I've been trying to get these through your head even before we got here. Zeros, factors, solutions, and x-intercepts. If you have a polynomial function, and I don't look like one with a bunch of a's in it, but if you have a polynomial function, the following things are equivalent. Means they're all the same. And I've been trying to get you to see this for a long time. A zero, k is a zero of the polynomial function. X minus k, if that is true, if k is a zero, then x minus k is a factor, they're related, k again. If k is a zero, k is a solution of the polynomial equation where f of x equals 0. And x-intercept is k. If k is a real number, k is an x-intercept if it passes through k 0, which means if it's a 0, you can write it as a factor. If 2 is a 0, the factor, you can write it as x minus 2. It means 2 is a solution. When you get done, you can say x equals 2. And it means it's an x-intercept, which means it crosses the x-axis at 2, 0. All of these words represent the same number, and I've been trying to get you to see that for a long time, and now it becomes official today. So those words, 0, factor, solution, x-intercept, all relate to k, all relate to the same number. Okay, they're going to have you do some rough sketches of graphs first thing today. A couple things you need to know about these things. First of all, we're going to use what we already know, meaning we know already whether this is even or odd. I have a 2 there as an exponent. I have a 2 here. This factor has a 1. Don't worry about the 1/6 because it doesn't have an x, so that means it's odd. Remember what odds do? Odds go odd positive because it's a positive 1/6. So it's going to go down to the left, up to the right. I know that for a fact. These are factors. X plus 3 and x minus 2 are factors, which means they're also solutions, which means they're also zeros, which means they're also x-intercepts. So that means I'm going to have an x-intercept at -3, also going to have an x-intercept at +2. Because remember, the factors, the zeros are opposite of what's in there. And I know the graph is going down, left, up, right. Now, one other thing that's new today is this. When you have a factor that has an even exponent on it, the graph doesn't actually pass through that x-intercept, it bounces off of it. So this graph, if I'm going to draw a rough sketch real quick what this graph's going to look like, I know it's going down left, so it's going to come up this way. It's going to circle back down, it's going to hit the 2 right there. Now because it's an even exponent on the x minus 2, it actually bounces and goes back up. So that graph is going to look something like that. That's a rough sketch. Now I could find more points to make it more exact in between the 2 intercepts and past the intercepts, but roughly that's a good rough sketch of what this is going to look like. All right, turning points of polynomial functions. On the last graph you saw on the last slide, we had 2 turning points, meaning a turning point, let me point this out to you real quick. Turning point is right there where it says local max and also local min. Those are turning points. That's where the graph turns from going up or increasing to going down, decreasing, and then going back up again. That's where the graph turns directions. Okay, a couple of facts about those. The first one, the graph of every polynomial function of degree n has at most n minus 1 turning points. So that could be degree 3 because it has 2 turning points. So whatever the degree is, it can have at most 1 less than that turning point. Number 2, kind of backwards, if a polynomial has n zeros, real zeros, it can have exactly n minus 1 turning points. So like that one, crosses the x-axis 3 times, has 3 zeros, has 2 turning points. That's true, it has exactly n minus 1 turning points. Okay, we call the y-coordinate of a turning point is called the local max or maximum, right there. The y-coordinate of a turning point, the second one, is a local minimum if it's lower than all the nearby points. So maximum, like the top of the hill, minimum, bottom of the hill, bottom of the valley, or whatever. All right, this one says estimate the coordinates of each turning point and state whether it corresponds to a max or a min, and estimate all real zeros and determine the least degree. Wow, a lot of stuff. So here we go. Let's go maximums first. I'm going to circle this. The only local max I see is right there. So, I'm going to say the local max would occur at, and this is an estimate obviously, let's say, I don't know, -1/4 and -2. That's a guess, maybe not a very good one. There are 2 local minimums. All right, the local min, there's 1 down here, which I would guesstimate about, I don't know, -1.5, and I forget the one, -1, let me do that again, -1.5, and down at 1, 2, 3, 4, -5. The other one is right here, which I would probably say is 1/2 and negative 2.5. And again, those are guesses. It said estimate. Also estimate the real zeros. The real zeros are the x-intercepts. There's 1 right there. I'm going to say that real zero. The zeros are at negative 2. And there's another one right here, which sort of looks like positive 1s. Those are my zeros. And then it says estimate, determine the least degree. First of all, I know it's even because it's going up. It also has 3 turning points. Remember, the turning points are 1 less than your degree. So I'm going to say the least degree it could have is degree 4 because it's even for sure. 3 turning points, 2 zeros is fine. So we're good there. What's wrong with the graph down here? First of all, remember these are factors, so it should cross the x-axis at negative 2 and positive 1, which it doesn't do. That's one thing wrong with it. The other thing is this. The zeros should be at negative 2 and 1. And remember, it should pass through negative 2, so it should pass through the graph over here. And when it gets to the 1, which is where it's supposed to hit, it should bounce off the 1. So that's more what the graph should look like. So there's quite a bit wrong with that one. We're also going to probably find max and mins on the calculator tomorrow, and I'd rather show you that in class. So we'll work on that in class tomorrow. And I guess I will see you then. Have a good one.